Alzheimer's disease affects more than 5 million Americans, a number that's expected to grow to 16 million by 2050. Early intervention can help to lessen the most debilitating of symptoms, namely memory loss and problems with reading and organizing thoughts. But unfortunately, it remains one of the most challenging neurological disorders to detect. No specific test for Alzheimer's exists. There might be hope, however, on the horizon. Researchers at the University of California's Berkeley Radiology and Biometric Imaging Department and the Big Data in Radiology group describe in a newly published study an AI system that can predict Alzheimer's disease from brain scans. Their paper was published in the journal Radiology. They aren't the first to apply AI to Alzheimer's disease research. Scientists at Unlearn AI, a startup that designs software tools for clinical research, earlier this year developed a system that predicts its progress. But UC Berkeley trained a deep learning algorithm on 18F fluorodeoxyglucose positron emission tomography. Whew, it's a mouthful. It's a specialized imaging technique in which patients are injected with FDG, a radioactive glucose compound which allows radiologists, and in this case an AI system, to measure uptake in brain cells through PET scans. It's an indicator of metabolic activity. The researchers built a project database containing more than 2,100 FDG PET brain images from over 1,000 patients. After training on the dataset, the AI could track minute changes in glucose uptake in certain regions of the brain that would be, under normal circumstances, difficult to detect. In tests on a separate set of 40 imaging exams from 40 patients, the researchers' AI system achieved 100% sensitivity at detecting Alzheimer's, an average of more than 6 years prior to the final diagnosis. This is huge, or at least it could be. The team cautioned that it's still early in the research and that the test sample size was relatively small, but they believe the system could be used to complement the work of radiologists and that it could serve as the foundation for AI that can identify patterns of protein buildup, abnormal protein clumps, and other biological markers associated with Alzheimer's disease.